Today's notes are going to be over using logs to solve exponential equations. Okay, so when we solve exponential equations, the kind that you guys are used to solving is equations that look something maybe like 4 to the x is equal to 8, something like that. And so what that would entail is both sides of this equation are powers of 2. And so you would be able to rewrite both sides as powers of 2. But not all exponential equations can be done like that. Not all exponential equations have the same base. For example, if I said 4 to the power of x is equal to 25. Okay, 4 and 25 are not powers of the same number, so you can't use the same base to solve them. So what we are going to use to solve them instead is we're going to use one of the laws that we used just a little bit before spring break, and it went into a box that looked like this, and it reminded you that your base has to be bigger than 0 and it can't be equal to 1. And before spring break, the version of it that we used said log base b of x is equal to log base b of y. And then what that meant was that we were able to drop the logs and the bases, and x would end up being equal to y. And so today what we're going to use is the reverse of that. We're going to use one that says if x is equal to y, then if you take the log of both sides, they'll still be equal to each other. So log base b of x is still going to be equal to log base b of y. And basically what we're using is we're using a law from algebra. And that law from algebra says that you just need to keep your equation balanced, that you can do whatever you want to an equation to solve it as long as you do the same thing to both sides. Okay? And so that's what we're going to be using. So the steps that we're going to follow, the first step to solving an exponential equation that can't be done with the same base is we have to get the exponential isolated. And so what that means is that we have to get the base and its exponent isolated. So if there's anything multiplied to it, we have to move it. Anything divided, anything added or subtracted, all of that has to be moved. And this is actually the same step that we've taken before. We had to isolate our square roots to solve our square root equations. We had to isolate absolute value to solve our absolute value equation. So we've seen this before. The second step is we just need to take the same log of both sides. Now the property just says log base b of both sides. And so technically you could take any log you wanted to. You could do log base 113 if you really wanted to. But of course the two logs that we predominantly use in mathematics are common log, which looks like this, and remember that's a log with a base of 10, and natural log, which looks like that, and that's a log with a base of e. And we're going to use natural log, this one right here, because it's the log that you use almost exclusively in pre-cal. And so we want it to be the one that you've seen used, that you're comfortable using, that it's familiar to you for next year. Once we've taken the log of both sides, then what we're going to do is we're going to use our log properties to move the exponent with the variable down to the front. And that was another one of those log properties that we reviewed the other day that says if you have log base b of m to the power of n, that n will move down to the front and become a coefficient. And so it would end up being n times log base b of m. Okay, and then the last step is technically, could be one step, it could be no steps. I mean, technically there are equations that work out that way, but what this last step is to isolate your variable. And so this is where you're going to be doing your rearranging. Okay, adding, subtracting, multiplying, dividing, the basic steps that you take to isolate your variable normally. So the first equation that I'm going to do for you is this one. And this one can actually be solved using the same base on both sides, but I'm going to do this new method to show you to get an answer, and then we're going to use the same base to check our answer. So we're actually going to do this problem twice. So step one is get the exponential isolated, and the exponential is the base of 4 and its exponent, which is the x we're trying to solve for. So we're going to add 16 to move it to the right side. So we will have 3 times 4 to the power of x is equal to 96. Then we would divide both sides by 3. And so we will have 4 to the power of x is equal to 32. Okay, and now our new method. Our new method says take the log of both sides. And like I said, we're going to stick with natural logs. So I'm going to take the natural log of both sides. When I do that, what happens is over here on the left side, I now have an exponent inside of my log. And so that exponent is now going to move down to the front, which is step 3. I'm using my log properties to move the x down to the front, so it becomes x times the natural log of 4 is equal to the natural log of 32. And then this time around, the last step, the rearranging step to isolate my variable, is just one step. I'm just going to divide by the natural log of 4. I now have x isolated. Now, what we're going to ask of you is that you do all of these steps first before you ever touch your calculator. And the reason we want you to do that is actually twofold. The first is that it avoids rounding errors. People tend to round their decimals too drastically and too early. But you also need to be able to generate an exact answer. Next year in pre-cal, you may or may not even have access to a calculator to do these problems. And so you need to make sure you're doing all the algebra steps correctly, and then you use your calculator as the very last step. So if you have access to a calculator right now, if you installed the TI Inspire, or if you have some other kind of calculator on your phone will do this for you. I want you to pause for just a second, and I want you to type this into your calculator and get an answer. Okay, so hopefully you paused. Hopefully you typed this in your calculator, and you should have gotten a nice, pretty answer of 2.5. And so this is your final answer. Just depends on if you are being granted a calculator for whatever it is you're being asked to do. Now, what we're going to do is we're going to check, and we're going to do the same bases to check our answer. Because you can see we came up with an exact answer, so we should have been able to do this one by hand without a calculator. So what that would have looked like is when we got to this step right here, so the first two steps would have been the same. And when we got there, what we would have noticed, hopefully, is that this equation, both sides of it are powers of 2. And so we would have rewritten this left side as 2 squared to the power of x, and we would have rewritten the right side as 2 to the power of 5. And so the left side would have been 2 to the power of 2x. It's equal to 2 to the power of 5, and so now we're able to drop our bases. And we have 2x is equal to 5. And when we divide by 2, sure enough, we get 5/2, which is 2.5. And so we can tell that we did this correctly. Now, before I move on to the second and the final problem that I'm going to do for you guys, I want to make sure that you understand that I'm going to have to erase because I don't want to switch pages. I want to be able to show you what I'm talking about. This answer right here is really commonly miswritten by kids, especially at the pre-cal level and higher. So just want to make sure that you are being very careful about how you write your answer. Natural log of 32 divided by natural log of 4 is not the same thing as natural log of 32 over 4. And you would think it would seem obvious, but a lot of the kids think things like, oh, well, this natural log is going to disappear because it's underneath this natural log, or kids do this when they're using their log properties to condense. They incorrectly, for example, if I said natural log of 32 minus natural log of 4, then what it should become is natural log of 32 over 4, and what we see a lot of kids writing is natural log of 32 over natural log of 4. And so you've got to be really careful that you know which format your answer is going to be in, and whether or not you are putting terms inside of a single log together to divide, or if you are actually dividing two separate logs. And that will also dictate how you type it in your calculator. You've got to be careful about how you type it in your calculator. So there's lots of things to pay attention to, little details where people could make mistakes. And then the last problem that I'm going to do for you is this one. It's 4 times e to the power of negative 2x is equal to 100. And I'm also going to do this one 2 different ways, but for a different reason than I did the previous problem. And this one can't be done in terms of the same base, so the 2 different ways are going to look different than the previous problem anyway. And so my first step is still the same. I still need to isolate the base and the exponent. So I need to isolate e to the power of negative 2x. So I'm going to divide both sides by 4 and get e to the negative 2x is equal to 25. And now I can take the second step, which is to take the same log of both sides. I'm going to go ahead and do natural log again. So natural log of e to the negative 2x is equal to natural log of 25. Step 3 says that this exponent inside of the log will now move down to the front. So I would have negative 2x times the natural log of e is equal to the natural log of 25. Now, at this point or at a later point, you can replace this natural log of e, because hopefully one of the things that you've refreshed your memory on is that the natural log of e is going to become just 1. But I'm going to not do that right now because I want to make sure that you understand that it's okay if you don't do it now. You can do it later, or you can not do it. It will still work. If you never turn that natural log of e into a 1, you can still type it in your calculator and get the correct final answer. Okay? So I'm going to act as if that natural log of e is just staying the way it is for right now. So to get x by itself, my last step is going to be to divide by the negative 2 and the natural log of e to move them both to the right side. So that'll get rid of the negative 2 and the natural log of e, and it leaves x isolated by itself. So technically, we could be done. We could just leave this as natural log of 25 over negative 2 natural log of e. And we could type it in our calculator. And so if you want to pause right now and you want to type it into your calculator as is, that's fine. Just be really careful because this whole thing needs to be included in your denominator if you're going to do that. Okay? If you don't want to pause, what I would recommend you do now, if you hadn't done it earlier, is go ahead and try to commit it to memory that this natural log of e is just 1. And so what that means is that you have your natural log of 25 up on top, and all that you have left in the denominator is a -2. Okay, so this is our final answer. It's our nice, pretty exact answer, because when you type this into your calculator, you are not going to get a nice, pretty answer. Okay, when you type this into your calculator, what you will get is approximately -1.609. Okay, now the other way is not really another way, it's just a way to skip a step, and sometimes more than one step. And so once again, we're going to pick up right about there. So the first step would have been the same. We still would have divided by -4 to get to right here. But when we take the natural log of both sides, so when we do this step right here, it's technically step 2. The shortcut, the thing that can save you a step or two, is to also remember the last set of video notes from last week, which talked about the inverse properties of logs and exponentials. And natural log and e are inverses of each other. And one of the things that you learned in January is that when you do the composition of inverses, when you plug inverses into each other, they cancel each other out and just leave what's inside. And so what that means is this natural log and this e are going to cancel each other out, and all that would be left would be the -2x that was inside. And so what that does is it completely removes the natural log and the e from the left side of the equation. And so what happens is now I just have this equation, this simplified equation to solve, and so now my only step to getting x by itself is to divide by the -2. And so I still end up with the same final answer. It really is just a matter of how many steps did it save me to do this. Okay, and so you still get that, which ultimately when you type it in your calculator will still give you this. So that's how you use logs to solve exponentials. And so as we did last week, I'm going to give you 4 practice problems to try. So the first practice problem is 6 to the power of x is equal to 152. The second practice problem is 3 times e to the power of 2x plus 7 is equal to 12. The third practice problem is 3 times 7 to the power of x plus 10 is equal to 250. And the fourth practice problem is -1/5 times e to the x minus 3 is equal to 17. So I want you to give those a try, and then we will have the live Zoom tutoring again tomorrow if you need us. Thanks, you guys.